So it's kind of, yeah, these things depends of course from service provider needs and capabilities of the devices that they have in the network, and of course other resources. One thing which is quite important, of course, that I bet that here I'm not the only one in the room that is not that fluent with IPv6 than compared to IPv4. And if you have a lot of personal supporting, not people supporting the service provider backbone network countering devices, how do they see IPv6? How do they understand how the protocols work there? So it's a question of training, good planning, etc., in order to successfully transform the network into IPv6 capabilities. So transport schemes from service provider point of view in a core network. So you have the IPv6, and then you just wonder what's the best way, either MPLS based or IP based. Many of the commercial service providers, they have MPLS enabled anyhow. So MPLS is practically every commercial service provider that are selling internet services and VPN services, they have MPLS. So MPLS could be used as a transport mechanism over the core of the network, and that works pretty well inside the AS number, but have some challenges if you have to go between the AS numbers, because MPLS is commonly used, especially not over the peering points. Maybe private peering is a different story. IP based, that means that you use different tunneling mechanisms described in a previous presentations as well. But here is principle picture that you have a version A of the protocol and you encapsulate it into version B of the protocol and use that as a tunnel. So there are a lot of tunneling mechanisms available that supports this. Many of the operators use tunnels anyhow in the network, and you basically point out that the next step for this routing of IPv6 packets goes over the network through this tunnel. So it would look like this one. Very easy because if you're talking about manual tunnels, very easy to troubleshoot as well. So it is just like a virtual link and so on. So it's easy to follow up how the traffic flows through the network, etc. It could be painful if you need to do a lot of them. So maybe not the best solution in that case. Then there are many automatic tunnel versions available as well. Not to go through all of them. Some of them are from host to host type of tunnels, and some of them are from site to site. And here I have 624 as an outdated as an example. Mentioned that the 6RD is the new one getting attraction quite a lot at the moment. And there's an example and story in the internet as well. You can Google it. It's the free, the French operator, the free, which was mentioned here as well. How they actually made it available in no time, practically in no time to 1.5 million customers. And so basically it shows how IPv6 private deployment can be used. That is something which is interesting from vendors and service provider point of view as well. So then turning to the MPLS, how to use MPLS as a transport mechanism. Let's take a deep dive there. There are many ways just to use the MPLS as such. As IPv4 at the edge of the network can use IPv4 MPLS enabled backbone. So the IPv4 packets are taking the MPLS LSP path through the network. IPv6 can use the same way, or you can use IPv6 in MPLS VPN environment as well. And also operators who have MPLS enabled, they can use layer 3 agnostic technologies like layer 2 VPNs or EPLS services in order to make the backbone transparent for the IPv6. But if you look into the two major schemes in IPv6 an MPLS environment is that use the normal MPLS encapsulation, LSPs. LSP is the label switch path through the backbone. So it's like a tunnel, but it's single based on the normal IPv4 routing. And you can point at the next hops through the network using the MPLS LSP instead of the normal interface next hop. That works with IPv4, and it can be used with IPv6 as well. It has some challenges. And IPv6 with VPNs is called 6VPE. It's an extension to the MPLS or IPv4 MPLS layer 3 VPN. So in case of 6PE, this is just that the router has a routing table for IPv4 and IPv6. It has different tables for multicast routes, etc. So it doesn't change the game in any form. It is not different than IPv4 routing. It just enables IPv6 at the router and lets it to use MPLS LSPs as a transport mechanism over the backbone. And IPv6 VPN practically does not differ from the layer 3 VPN for IPv4. So this is an illustration of the simple situation that you have a core network with IPv4 only and MPLS enabled, but not IPv6 enabled. And then you have this blue clouds here to say as IPv6 enabled customers perhaps or separate networks. And the normal signaling between the core routers works like normally with IPv4 and MPLS. In IPv4 case, IPv4 packets can take the MPLS LSP as the next hop, and that works fine. In case of IPv6, there is a problem because there's a terminology called PHP, which is penultimate hopping. And now everybody knows what the hopping is in MPLS, but it means that when you have an MPLS LSP, it means that you're using labels for each of the physical interfaces and the hops to the next router, and that is typically one label stack deep. Or if that is in case of VPN, you have two labels in a stack. The second last router before the egress pops the top label away in case of penultimate hop hopping, and because that is the penultimate hop router. So it takes the label away, and if that is a B router, which is a core router, and has only IPv4 enabled, and now you remove the label, you see IPv6 packet, and the router says, "Mark, I don't know what that is," and drops the packet. So it doesn't work. So we have to use explicit null label in order to keep the label there on the last hop, second last router, but IPv4 and IPv6 are using different labels there. So we have to create an extra overlay for IPv6 traffic for over the MPLS, because the same IPv4 labels cannot be used on the same LSP. So it means double amount of LSPs, but anyhow it can be used. So this is the scenario with IPv4 over LSPs. So we have IPv4 packet going through the LSP, and the labels are spread on its hop. And as you can see, between B2 and BP2, there's only IPv4 packet because there's an explicit null or implicit null label used, and it works with IPv4 but not with IPv6 in case you haven't enabled IPv6 in the core. And this is the model with IPv6 over MPLS, that you use AFI and SAFI values to create AFI is for IPv6 and AFI1 would be IPv4, and the SAPI4 means it's MPLS in question. So that is multi-protocol with BGP used in this case. And when we talk about IPv6 with VPN mechanism, it doesn't change the game at all. Basically, the AFI values are different, but that's everything. So this is the normal situation where you would have in case of layer 3 EPN and IPv4 world, but now the routing protocol between BE and CE is IPv6 enabled, and IPv6 is enabled in a VRF on the BE as well. So this is from service provider point of view in a core, but then, and that's quite easy, but the real challenge of course is that yes, because of the IPv4 addresses are growing there, not in a core. So one thing is to maintain the IPv4 paradigm as much as possible, so don't do anything. Don't enable IPv6, just play against the inevitable. So that means that you need to do something better than you did earlier. So today you're using NAT in every CPE, practically every consumer CPE of this is doing NAT. But that doesn't scale anymore because the amount of customers in broadband network is growing too heavily. So you need NAT 444, which means that you enable NAT second time in the aggregation level or the core network in service provider network. But then again, you could start that action with existing IPv4 accounts that you have. And if you need to deploy more IPv4 addresses, maybe this NAT 444 is the answer. And then at the same time start gracefully to deploy more IPv6 and a network perhaps for the new customers, etc. by using dual stack kind of technologies because of the fact that the translation techniques have some challenges anyhow. Or you could do it vice versa. And you have to do it vice versa because if you enable IPv6 in the first place and you have this kind of chicken egg problem that this is there first. IPv4 content is there, IPv6 content is not there, and how to make them work fluently is a challenge. And a DS Lite was described earlier. I have a couple of slides of it as well. And carrier grade NAT is the huge NAT device, which is a router with perhaps hardware assistance to do the NAT in a core of the network. Then dual stack, as mentioned, this means that you practically enable IPv6 and IPv4 in every node. Well, where does that take the IPv4 addresses then? They still keep growing. So if you get a lot of new customers in the network and you give them now IPv4 and IPv6 addresses, you don't get anywhere from the fact that IPv4 address is running out. So that's a challenge there anyhow, even though using dual stack in a host level. In principle, it could be used that if you enable IPv4 and IPv6 in every host, that then you would have bilingual devices and DNS bilingual service as well. So if you get an IPv4 address from DNS, then you know the device speaks IPv4 and vice versa IPv6 in case of IPv6 response. Consequences could be that what about if you get both answers? So what to do then? So some challenges there as well.